So I
Hello.
am joined today by my esteemed panel, Tim Vale, who's been on this with me a couple different times. Thanks for joining me, Tim. Tim, what do you do here at Cockroach Labs?
I am the head of sales engineering here at Cockroach Labs.
Right, and you've been in the data space for how long?
Oh gosh, long time. I mean, we'll probably end up talking about this, but I came to this this side of the business for many years as a software developer and engineer. So I really kind of feel like that's what I do, but have worked for a number of data companies, built a bunch of applications, obviously using data. So lots of varied experience. Coming to you
Awesome.
live from Atlanta, Georgia, by the way.
That's right.
Dark basement.
From the vault.
From the vault.
So this is a good mix, actually. So Tim, you come at this from more of a developer point of view. I think I share with your side, but we're also joined by John. And John, you've been deep in databases for really quite some time, right? So what do you do at Cockroach? And just a little bit about your background.
Yeah, so I'm also a sales engineer. If Tim is the head of sales engineering, then that would make me
the arm,
someone who works for him.
An arm, maybe a side, a liver. I don't know.
I was gonna say, what do you? The feet? Where are you going with this? Okay, you're on the team.
Yes, I'm on the team. Yeah, so I started off at Oracle back in 2000. So I started as DBA and a database developer, and then spent the better part of a decade there. Worked with Oracle RAC when it was first coming to market. And then since then, been at a variety of different startups in the Bay Area, data warehousing, big data, BI tools, AI, that type of stuff.
Right.
Yep.
But John, you've only been with us for about 3 months, and it's funny. So it's when Tim and I were talking, oh man, we're going to do this thing about isolation and database issues, and it was a no-brainer. I think I didn't even get the sentence out. I was like, who on your team? John. He was like, John. John, you've been dealing with these sort of consistency problems and understanding these things really for quite some time, right? I mean, this is kind of your background, right? You're I guess what I'm saying, you're our expert in this whole thing. I think Tim and I are just here to talk to you.
Well, if I'm our expert, then maybe we're in trouble. but yeah, it's been, honestly, isolation levels has been an area of confusion for the 20 years that I've been working with databases. I mean, honestly, it probably took me many years of working for Oracle, a database manufacturer, before I really understood what was happening in transaction isolations. And then, so it's an easily and widely misunderstood topic. So I'm glad we're talking about it.
Yeah, and I think it's one of these things that as a developer on that side, well, I'll play the marketer, but I'll come back to you, Tim, for a second. As a developer, you don't think about these things. You just say, like, look at the database is up and running, isolation. I can set that. Like, what does that even matter to me? It actually matters, because ultimately a database, to me, has to keep data. And if you have wrong data, then that's not good, right? I think it's one of these concepts here at Cockroach Labs that we take to heart, because in distributed system, it adds a wholly other layer of complexity to these questions. But I want to start the conversation with isolation. And so that's the I in ACID, right? So I'm going to start with you, Tim, right? So, let's just clarify for everybody. We're talking about the I, not the C in ACID, right? So what's the difference? What's the C in ACID versus the I in ACID? We lost him already?
I thought you were going to make a joke about isolation, like COVID-19 isolation. I thought.
Yeah, right. Uh-oh. I think he's on his own. I could take this one, but go on, John.
Okay, I'll take it. See, this is why. That's why he's the boss, and he invited me. Right now, I know why you invited me to the call.
Exactly. Thank God.
Yeah. So isolation is really about when you connect to the database and you're in a transaction. It's really like, what side effects from other transactions do you see within your transaction? It's isolation. So consistency is more about, like, if let's say you updated a record and then I read the record. A consistent database will make sure that I read, if my transaction came after yours, that I will read what you updated and I will not read the thing before. So consistency is about making sure you get the right answer. Isolation is really about what you see within your transaction and what side effects you see, and ideally you would see none. but what side effects you see from other things going on in the database while you're in the middle of your transaction.
Right. And that's that. Timmy, you.
Oh, I was just going to say, thank you
Yes,
for
he's
covering for
back.
me there. That was not an attempt to avoid the question.
I don't think he wanted. I don't think he
No,
knew the answer, John.
That was like the only question I could answer, so I really wanted to answer it.
I've learned the trick now.
No, I tried to minimize Zoom and like everything disappeared on me. And so I was like searching for putting Windows back. Anyway, sorry, everyone. But great job, John.
And I think, John, I mean, so ACID transactions is, you know, if you've ever dealt with a database, we don't need to get too deep into it, but I do find it kind of important to actually understand what those terms, the ACID, actually stand for. Durable's easy. Yeah, it's going to be up and running. We think a lot about that here. But I think, you know, sometimes people will confuse a little bit the isolation level with consistency. Consistency also has to do with like referential integrity and a bunch of other things as well, right? And so one thing though, and it is kind of related to this as well, the A is ultimately important as well. So I'm going to come back to you, Tim, just to make sure we'll test you on your ACID compliance here. What is
atomicity? Atomicity,
right,
my friend. Yeah, so I think, you know, the key concept here is that you know, transactions are should be, you know, treated as kind of a single unit. They, you know, they either fail or they succeed in unison as a single unit.
As an atomic unit.
As an atomic unit, right? So that's kind of atomicity, atomic, you know, that's the idea is, that's the idea behind atomicity or the A in ACID. But the reality is, you know, all four of these things need to be working kind of in concert together. And one kind of interesting thing to note, which we may be, I know we're going to be discussing in greater detail later, is that the only one of these kind of letters that is really has any variation or variability at all is what we have kind of led or what we have evolved with isolation, what has evolved with isolation. So, you know, there isn't a lot of wiggle room with atomicity. There isn't a lot of wiggle room with consistency. There certainly isn't a lot of wiggle room with durability. These are kind of A, B, binary, yes, no kinds of things, but it's isolation where things get a little bit wacky and weird, which I know we'll be talking about.
Yeah, well, let's just go there. So, John, you know, what are those levels, right? I don't think everybody totally understands what they are. I think I had to really start to figure out like what linearization versus serializable, what like, there's a whole bunch of things. So let's just start there. It's a great conduit, Tim, to that part of the conversation. So what are the isolation levels?
Sounds like an isolation level test, but I'll try to do from memory. So the first thing to remember, I think the easiest way to think about this is, actually, if you do a Google search for database isolation levels, there's the Wikipedia page.
It's great.
Is a good one, but
it's really amazing, actually.
Yeah, and they typically present it. I think it's read uncommitted, read committed, repeatable reads, and then serializable are the four main ones. And there's some other levels in there. You're going to look it up and see if I got that right. And they typically, when people talk about it, they talk about the loosest one first, and then they eventually get to the purest one, which is serializable. I actually like to flip it upside down and talk about serializable, because serializable is the easiest one to understand. And serializable is where if you're in a transaction, yeah, there you go, bringing it up.
Yeah.
Did I get it right? Yeah. So I got, oh, actually, I stand corrected. They do it in the way that I like to talk about it.
Yep.
Serializable is the easiest one to understand, because when I'm in a transaction, I only see what I'm doing to the database. So the database state changes only from what I do. And so people will describe it as being like your transaction is the only thing happening on the database. That's from a view standpoint, that's correct. Now keep in mind, that doesn't mean that every transaction has to serialize behind each other. That's a misconception, because like Jim, Tim, and myself, we could all be updating different rows in the database and in different transactions, and we could have a completely serializable, completely a separated view of the transaction.
That's right.
Nothing that you're doing and nothing that Tim's doing is impacting my transaction. So we can still go in parallel. It's just the database it can take those transactions, essentially stack them into a serializable form, because they don't conflict, right? And then these other ones, repeatable reads, read committed, and then read uncommitted, are all relaxations of that isolation. So like read committed, for example, when you start a transaction, you run a query, and every time you run a query, you're going to see what's committed at that point in time. So let's say I run a query and I see a table has 10 rows. but then Tim deletes 5 of the rows. If I run the query again, I'm going to see that there's 5 rows. So in my session, I'm seeing side effects from other transactions, and that's what's happening in like read commit.
Right. Right. And so basically the side effects is what ends up having problems with your data, right? You have these phenomena with these issues. I want to come back to something you said around serializable too, John. And I think, it took me a while to actually understand the difference between serializable and linearized. I think you'll hear that term is right. Correct me if I'm wrong. Linear is actually physically like they happen in order, like there's a clock and there's a time thing, right? And I think it's actually pretty important. Like that serializable thing about things can actually happen at the same time, right? Like it's different than linearizable, right?
Yeah, absolutely. So,
Yeah.
I mean, if you think about it, the isolation levels are a contract that the database is giving you about what you can see, what side effects you see in your transaction. And linearize is basically a way of the database saying, in order to guarantee that we have no conflicts, the database, am just going to run them one after another, and nobody can do anything in parallel.
Right.
Serializable says you can run them in parallel, but the database has to guarantee that these transactions could be logically serialized, right?
Right.
And if they can't, then the database has to tell you. It has to tell you as the application developer. It has to say, there's something went wrong, there was a conflict. I could not guarantee that isolation, and so here's an error. Application, you should take the appropriate measure.
Right. So let me just turn this back to Tim, right? And so from a developer point of view, Tim, what do they need to know across these different levels, and what's important, like at the highest level, right?
Yeah, it's a great question, because if I'm being brutally and painfully honest, for many years, I didn't understand what these things were. I didn't have a reason to really know. I just kind of took it on faith that the default levels of isolation of the database that I was connecting to were sensible, and if I
it wasn't going to lose data and it was going to be fine.
If I was using an application framework like Spring, and I wrapped something in a transactional annotation or was otherwise kind of managing transactions, I thought everything was fine. Geez, if the transaction completes, then everything must be correct and must be good. Well, there's a lot more happening under the hood, as we've been discussing. It's not so much anymore that the transaction passes or fails. But with the variability of isolation levels, what can happen is a transaction can be successful. Your commit can go through. It can be an otherwise considered valid transaction, and yet anomalous behavior can happen in the data. You can, we'll talk, I suppose, about all the different things. So from a developer perspective, I think it is really important. I think it's really important to A, understand the isolation level that your database is running. B, in your application code, understand how you are managing transactions, understand the transaction boundaries, the lines of demarcation, when a transaction is started, when a transaction is committed, what rollback philosophy that you have or approach that you have. It really is fundamentally important, particularly because of concurrency and all sorts of other things that happen.
That's right.
Just last thought, because I know you want to jump in. I mean, if you're out there building, simple applications where 1 or 2 users are hitting every 5 minutes, big deal, right? But that's not what we're talking about here. That's not what Cockroach is built for. It's built for, high scale, high throughput, enterprise class applications that are getting a tremendous amount of traffic and volume. And when that occurs, you need to have a really deep understanding of what transactions are, isolation levels are, and what ultimately is happening with your data under the hood. Else, you're going to find yourself in a world of hurt if you're an application developer. Something you thought was working is actually broken.
Yeah, Tim, I like to think about that as just like the correctness of data. And then you kind of touched on 2 other vectors. And, John, I think we'll come back to performance and the impact of this on performance, but these things also have an impact on security, correct?
Yeah, I mean, because what happens when if you can affect a transaction, if you can manipulate what happens in that transaction from another transaction, you can now if you can get in and do things, either do a SQL injection attack or something like that, and cause some sort of side effect to happen within the transaction. You could do things like overdraw an account in a very simple way. You can expose bugs in the application that are bugs because the developer never thought about some side effect that could happen. And because, you know, who does that, right? No one's sitting there going, okay, what are all the possible ways this could go wrong? And let me write code to handle that.
Right, because you basically have developers like Tim who are like, I don't know, whatever.
Oh, I
Right?
just, I put the spring transaction annotation on my method. Everything must be right, right?
Right.
It committed, so it's right, wrong.
Yeah, yeah. And I think, to me, that was one of the things that lit my eyes up when I really started investigating this, like the issues, the security issues that can go wrong. And it's one of the reasons why, you know, we work with a lot of financial services companies. You know, Tim, I've known you for years. You know, we've been dealing with, you know, FinServe and any of these kind of system of record type applications where they are dealing with like financial transactions. That's where this stuff gets really, really important. But I think it actually has impact on our day-to-day applications as well, because I mean, honestly, like, what is data but you know, that's most of the value in an organization is in their data today, right? Like, so.
Well, yeah, absolutely. And, you know, just maybe to take a step back, I know, you know, what Cockroach does is second nature to us, but I mean, you know, for those who may be just joining for the first time, what is Cockroach? I mean, it's a transactional OLTP database, right? We're not talking about an analytics engine where, you know, you're doing kind of, you know, cubes and reporting. We're talking about a heavy read-write transactional kind of heart of the business system where if something is wrong in that heart of the business, the mistakes can fan out to all sorts of other systems. So, you know, kind of classic example, my transactional system, if that's incorrect, any reporting engines or analytics that I do based on that data is wrong. So that, you know, it's really important for your core data set and data to be accurate at all times because it influences so many upstream and downstream systems. And so that's why, you know, it's not like we just woke up one morning and decided this was going to be important to us. I mean, we're building kind of the world's greatest OLTP engine. And as a result, data correctness is critically important, more so than it would be potentially in, you know, kind of upstream or downstream systems.
Right.
So it's something that we have to take very, very seriously and do take very seriously.
Right. And the data correctness is a big deal. So I want to tie off just on this section and we'll get into some of these questions. There's some really good questions coming in, you guys. So please do continue to ask away. I think I saw John reading some of them, so he had some answers. But John, let's just come back and just tie off on performance really quickly. Sure. You know, these things do have an impact on performance, however, correct?
The isolation levels?
Yes, the isolation levels. Yeah. Yeah. Before we tied off.
Yeah, I mean, the performance comes into, excuse me, how the database management system is able to basically guarantee or control the isolation level. So if you think about it, the isolation level, I like to think of the isolation level as a contract that you have with the database about side effects from other transactions. And if in order for the database to be able to guarantee the side effects aren't happening, it needs to do things like locking and multi-version consistency control and all these different types of things. Different databases handle that differently. And so that is why, you know, some databases, especially legacy databases, defaulted to lower isolation levels, is because at the higher isolation levels, performance was a problem, or they would just get too many, they would have to have too many transaction aborts, because of they couldn't precisely figure out when a serializable isolation would be violated or not, and that's a deeper topic. But
yeah, well, I think to me it's a very, very important concept to cover. Before we're going to move into the more advanced topic around distribution and isolation and distributed systems next. And see you guys, I got the hand waving going. We'll go into that next. But I just wanted to tie off on the performance thing. It's actually pretty important when you are running benchmarks or you are looking at one database versus the other. You know, there is a vector of correctness here. You know, like we run TPCC, we publish everything. You know, if you go to our product section of our docs, we have a whole performance section that talks through what we do. But all of our performance benchmarks are run at serializable isolation because that is the default level in CockroachDB. That's it. There is no other level, right? We've done some things to improve access via follower reads and some of these other things, but I think it's actually a pretty important concept to think about when you start thinking benchmarks and that sort of thing. Go on, Tim.
And I was just going to double click on that because I was kind of typing a similar answer. to somebody in chat. I mean,
Mm-hmm.
one of the quick notes, and you mentioned it, but I just want to go back to it, is, we're having a good discussion about what the different types of isolation are, levels of isolation, and the impact they have. But the reality is Cockroach only runs at serializable.
That's right.
So it's important to know what these other things are as a way to compare and contrast what we do here at Cockroach. But the reality is Cockroach only runs its serializable isolation. You can pass in another value, we'll ignore it and run your transaction at serializable. Because again, one of the fundamental core beliefs of Cockroach is the data must be correct at all times. And the way to ensure that at the database is to implement serializable isolation or run a transaction at serializable. We can talk about workarounds, which again, you quickly mentioned, but just want to make sure everybody understands that there is no option here at Cockroach. It's serializable or bust.
Well, which is actually a perfect conduit. Go on, Johnny. We were going to talk about locks and why this is important in distributed systems. I think that's where you're going, John, right?
Well, no, I was just going to say, I was going to say that, when I was first taking a look at joining CockroachDB, and I read the documentation that said they only support serializable. My kind of natural gut reaction was like, oh, why is that the only isolation level that you guys support? And you start wondering, it's like, is that a limitation of the product? Is that you have to do it that way? And as I kind of read into it, and honestly, I had to go study isolation levels again to kind of remind myself what these various different things were like. What I realized is you want serializable isolation. That's what you really, really want. Everything else gives you less isolation, and most databases just can't pull it off. They can't pull off serializable. And we can get into more detail about this. But the way that CockroachDB tracks multi-version consistency control at a record level makes it so it can do serializable in a distributed fashion, or it's distributed platform. And so, there's no reason to have a relaxed one, because we can do serializable fast. And if you can do serializable fast, you want serializable. There's really no reason to relax it. So I just wanted to share that perspective, because I kind of went through that mental journey when I was looking at CockroachDB, and I'm sure other people are probably thinking the same thing.
Well, and it was an architectural choice by the founders of the company, right? Like the Peter and Ben and Andre and like all of the engineers who built this from the ground. It was an architectural choice because of some of the complication that distributed systems actually provide to a database, right? I mean, we're talking about a database with multiple nodes trying to manage transactions in a broadly distributed environment. That's like, it's hard enough to do this in a database by itself in a single instance, like let alone do it in a distributed system. I always like to talk about that. So John, how do we do it then? I mean, how are we? I know it's kind of hard to do it without like visuals and stuff, but like, because I mean, I think about traditional databases. There's locks on rows. It's pretty simple in a single instance, and we have a fundamentally different approach, correct? And how does transactions work then within Cockroach? Was a good jumping point into. I think there's a lot of questions here about locks and that sort of thing. I just want to I want to move us in that direction so we get to these questions as well.
Yeah, so I'll do my best to try to explain this, but this is a deep topic. The good news is that it's we actually cover this in our docs under the architectural section. So, but I guess fundamentally, and I'm going to try to distill this down to its basic essence. Fundamentally, CockroachDB stores records way under the covers as in a key value store, right? And so just to be clear, CockroachDB is not you don't use it as a key value store, you use it as a relational database, but way under the covers is a key value store. And so that means every record is essentially a key value.
That's right.
And so CockroachDB uses that key value store for all kinds of stuff, transaction records, raft logs, all that kind of stuff. They're all just key values in this key value store. And so every time you make a change to a record, we're going to version that record. We're going to create another version of the record. And we have timestamps. There's all kinds of optimizations in terms of timestamp caching and all that stuff, which is documented in our docs. But any transaction at any point in time can find out exactly what the state of a row is in terms of MVCC, and therefore what's happening in other transactions, by looking at what are the rows, and then what are the new versions, and if they're uncommitted, we call those write intents, as well as the transaction records themselves. It can go read all this information, and it can figure out if someone has changed something that it's working on. And so if you're in a transaction at CockroachDB and it's doing something. When you go to commit, or at any point in the transaction, it can figure out, it's like, is this a safe? Am I isolated? And it can go and it can figure out what are all the different changes that have happened around me. And if nothing has changed and everything's okay, it allows you to commit. If someone else has changed something and it can't resolve it, then it's going to abort one of those transactions, you know, and
Right.
so that it removes the conflict by aborting one of the transactions.
Right.
So fundamentally, it's the idea that we have record level MVCC that allows us to do this really at scale in a distributed environment. Because keep in mind, traditional databases stored rows in blocks. You might have 32K block, you might have thousands of records or 1,000 records
Right.
in that block. And they would keep track of MVCC at a block level. So when someone updates a record in a block, that whole block gets versioned. Now, if
Right.
you update a record and I update a record and Tim updates a record, 3 totally different records, but
All
all
in
in the
one
same
block.
block. Now the database management system has a problem. It's like, how do I know exactly what has changed?
Right.
And so if traditional database management systems were to use serializable, you'd get transaction aborts all the time. So to make it so that it works, they said, well, you know what we can, within a block, we can figure out what was committed and what was, you know, not committed. So we're going to relax the isolation so that we can move faster. We can have less locks, or they can move faster, have less locks, and have fewer transaction aborts.
Right.
I
So
think I
John,
just dumped a lot of stuff on you. Yeah.
oh no, there's actually, so you lit up the questions, like the chat at the QA just lit up. Like, but this is the point, right? Like, this is
Yeah.
a complex topic, and I think there's a lot of places we can go with this. I want to come back to something that you said. I'm going to come back to MVCC and just an explanation what that is in a second, because I think that's actually a pretty important concept for people to understand. You just talked about transaction aborts, right? And so I think Tim's in the middle of questions. So this is kind of more of a developer question. What
Yeah.
does a developer have to think about when there is serializable isolation? Because you are going to have these issues, right? And so, like, what right?
Yeah, and so I'm furiously typing away
I
and
know.
trying to
I
answer all
saw
these
you.
questions. So I'm like only partially listening to John. Whatever he said, it sounded amazing. Good job, John.
I'm trying
But
to summarize it for you right there.
actually trying to type an answer to this question right now, which is, you know, what do we do with like kind of deadlocks,
Right.
or to your point
Right.
more generally, like what happens when things go wrong from an application developer perspective? And there is something
Right.
that we recommend, and you know, it really shouldn't be considered so much a Cockroach specific thing as much as really any distributed system, and certainly any distributed database that implements serializable isolation. Your application code should implement retry logic. What do I mean by retry logic? I mean simply, if I'm going to save a user record, I want my application code to be able to automatically retry that save without user intervention, or without end user intervention. So lots of great ways to handle this, lots of good examples on how to do this. What will happen is if Cockroach, for example, cannot uncover or determine kind of the correct order of operations, we'll throw something called a retry exception, or retryable exception. There's a bunch of different little details there. But the reality is your application code should know how to catch this and retry whatever it was you were originally trying to do when these things occur. Again, they're great examples across all different languages. I come from a Java background, and I do a lot of Spring. Spring and Java have some really great tools for this. There's a Spring retry project, for example, that's out in the wild that makes this very easy to do, either from a kind of a declarative or imperative point of view. So generally, that's what you have to think about with Cockroach. Everything else is the same from an application developer perspective. Obviously, know your isolation levels, et cetera, et cetera. But for those operations, particularly writes or specifically writes, you're going to want to wrap that in a nice, clean kind of bit of retry logic.
Right. And this is one of the reasons why I stopped being a developer. I was just a really bad, lazy developer. I didn't want to deal with retry logic and all this craziness because it's a pain. But there are frameworks, and I think there's ways to actually do it. And you have to deal with it. I think it's like, that's just good practice. Like, that's what separates good from bad coders, honestly. Like, in my opinion, I was horrible.
And I think that, again, that's the key, you know, because we get this in the field all the time. Well, geez, you know, my last database, or your competitor, doesn't require me to write retry logic. Well, A, we don't require it. And B, that's because whoever you're comparing us against probably isn't running at serializable isolation, and therefore is hiding anomalies from you. And so
Right.
trust me, you want to run in serializable isolation, and then you want to wrap this in retry logic to get it right. Because the alternative is bad news.
And even,
Yeah,
go on, John, please. Yeah.
yeah, I was just going to say, so incidentally, on this whole idea of retry logic, so I sold, or I helped, customers with high availability database solutions for many years. And the general pattern for high availability is also to have a retry loop, right? Because if you're talking to, your application's talking to a database and that database goes down and then you need to fail over automatically to another database, that's going to throw transaction errors, right? And so generally a retry loop of some form is just good for all kinds of reasons. Transaction isolation is just one of them, but high availability is yet another, and that's not unique to CockroachDB. It's in many other systems as well.
All of these concepts are not unique to, it does get unique when you start dealing with a distributed database for sure, right? And but a lot of these concepts, we could be talking about a single instance of a DB and there's still these problems, right? And so, John, I want to come back to MVCC. And I know you kind of glossed through that term. Just explain to me MVCC, just to level set with everybody. That's my job here on this, to make sure everybody's included. We have inclusion, all levels of understanding. So can you explain just MVCC and what that means?
Yeah. When I signed up for this, I didn't realize it was going to be like a online
interview
dude. With 82
but it's
people.
fun, John. It's fun.
I will do my best.
Welcome to the team. 3 months in. That's what you get.
Yeah. My general approach is to study some super complex concept and then net it out to something simple that I can remember. Exactly. And then I just explain that because I can't remember all the. But fundamentally, so multi-version consistency control, and any of you Oracle folks, when I was at Oracle, we would call it multi-version reconsistency. But so MVCC is basically this idea that let me give an example. So let's say that Jim, let's say you and I share a bank account, and we both go to an ATM. We both go to ATMs in different spots at the same time. Actually, it doesn't matter for different spots. We both go. So we both go and read our bank account. And so let's say it's $10. So you see $10, I see $10, and then you go to withdraw you go to withdraw $5. So you should see $5 in the account, but multi-version consistency control, I should still see $10 because you haven't committed yet. You haven't pulled that money out yet. Now, if you pull the money out, then then there's only $5 left. And then if I were to go try to remove $10, then the database should throw an error and say you can't do that.
That's right.
But if you were to say, actually I don't want to pull that $5 out, I'm just going to roll that back. Then within my transaction, I should have always seen there was $10. I should have never seen that you tried to pull out $5. And so multi-version consistency control are the mechanisms, and that's a generic name for how databases do it, how different databases do it.
Yeah, that's right.
They do it differently, but it's basically the way of saying that within different transactions, we can have different versions of the state of the database. But the isolation levels are responsible for making sure that all gets resolved, right? And so that's why I keep saying it's a contract with the database as to what you see and what happens.
Right. And I think it's part of the overall kind of story of what we've actually implemented. In our version of MVCC, it actually fits what we're doing with serializable isolation as well. And it comes back to like different databases have different levels. I like to think about eventual consistency or casual consistency as loosening these things, but you loosen them to accomplish other goals, right? And so, well, cool. Tim, you have been deep in some of these questions. Is there any one of them that you want to actually pull out and talk through?
I do. It's not strictly related to isolation levels, but certainly very much kind of within the same vein of an understanding of Cockroach, and that is CAP Theorem. So I think there's been a couple questions about kind of CAP Theorem. Where do we fit? What the heck is it? I don't know what it is. No, I'm kidding. I do know what it is.
Nobody does.
CAP Theorem. Nobody does. Nobody really knows. But CAP Theorem, it's what is it? Consistency, availability, and essentially P for partition. And for us, what it means is you're either AP or CP, right?
That's right.
It's kind of essentially the two options you have. And what it's really saying is, which do you favor in the face of a network partition? Do you favor being always availability, or do you favor consistency? And, we've obviously in this conversation been talking a heck of a lot about consistency, and isolation. So it's probably an easy guess as to which one we are. We're a CP system. But, in other conversations at Cockroach, we make a big deal about our survivability and the fact that we're highly available. And we certainly are. And there are lots of reasons for that. So in those conversations, it comes kind of as a bit of a surprise that we're not an AP system. You talk so much about survivability and high availability that you're not AP. And the reason is for all the kind of reasons we've discussed here. We really think correctness is kind of the utmost important thing. Again, why? We're an OLTP transactional kind of heart of the system type database. And so if there were to be a failure, a network partition, and how is Cockroach going to respond? Cockroach will stop forward progress on the database, essentially make the database unavailable in order to guarantee that we are providing a consistent or correct response to an end user. We'll always favor consistency over availability. We'll stop the database if we can't figure it out. And that's
right.
really, really important. And we can talk about all the other things that means. But again, if you're a database and you want there to, and correctness is important, which we argue it should be, I don't know why you'd be anything else.
Right. And Tim, so so availability, so let's talk about that. Let's just ask the next logical question. It's like, okay, since we're CP, so what does available mean to us? I mean, we're a Cockroach. I mean, that's the name of our company. The thing is, always on, always available. You can, how do you balance that then in that conversation?
Well, there's a couple different ways to answer. One of the things where I thought you were going to go, so I was prepared to say was
that's why I stopped, because I saw you. I see you had something. I was just like, I'll just let him go.
But what I was going to say is, well, if you're CP, what does AP mean, right? Well,
right.
AP means what can happen is that a cluster that has been potentially partitioned in some way will continue to serve reads and writes, but is sacrificing consistency. So that's right. A real big problem, right? Because what could happen is, one half of the system could continue to be served reads and writes and potentially serving inaccurate or stale data. And this is, this could be a whole topic of its own, but there's a real challenge for OLTP engines that do that. If it's an analytics engine, okay, fine.
That's different.
It's kind of different, right? But if you're doing what we do, then this stuff is really important.
If your primary motive is to become like a CDN, then okay, be AP. Sure. You know what I mean? Like, sure. Don't worry about that. It's almost kind of like Mongo versus Cockroach here, right? Like it's like AP versus CP in some ways, right? Because you're actually suffering some consistency issues. You're eventually or casually consistent, I like to call it, sure. Versus, and I think that's the choice for your application. I mean, there's a whole language conversation, everything else we can get into, but that's kind of shortcutting it, right?
Yeah, and I think maybe just to wrap this up so as not to leave people hanging, because I think this is where you're going. Well, geez, if you're a CP system, then are you unavailable a lot, and what does that mean? Can I not rely on you as a database? And the answer is, we are an incredibly resilient database. That's why we're named Cockroach, because of all the nasty little things that implies. Certainly, its ability to survive almost anything. And a well-architected Cockroach cluster or database is one logical database that should consist of nodes participating from a wide geography across different distinct, regions or availability zones or power grids or cloud providers. And so the idea with Cockroach is you have this one logical database that spans all of this infrastructure. So yeah, you could lose a wide swath of that infrastructure and continue to serve reads and writes because you haven't taken out a majority of nodes. And so, the reality is Cockroach is really, really hard to kill. A well-designed Cockroach cluster is really, really hard to kill. We'll serve reads and writes. We'll make forward progress, in other words, under extreme failure scenarios.
That's right.
But the key here is it will always serve correct data when those failure
That's
scenarios
right.
are occurring, not, oh, well, shit, shoot, something's gone wrong. Here's what we think the data should be, right? It's always going to be correct. And my
And I think
apologies, I used a naughty word.
Tim, it's okay. I'll invite you back. You're still welcome here. The what's interesting, Tim, you also talk about, like the AP side of things. We're talking about like mass transactions here. And so like we're talking about like thousands and thousands of transactions. We're not talking about having a single write node. This is for reads and writes. This is for every node in the system. Like, yeah, I think it is one of the kind of lost things when people talk about like cloud databases. It's like, yeah, I have read instances all over the place, but I only have one single write instances. That's not a distributed database in my opinion, right? Like that is okay. Like I have distributed storage underneath, but like having a single write node is a problem, right? I mean, just to tie off on that, it's kind of one of those things that I get really kind of passionate about because that's not a distributed database. That's basically using distributed storage to give you coverage for reads, but not for writes. And we need to talk about both writes and reads in this context, right? So I think it's really important. John, did you want to jump in there?
I was just thinking, I mean, again, on a side, kind of a tangent, which could open up, that's probably a whole webinar just by itself. But, I also think that there's a difference. So, you talked about the replicated databases, which you have the new terms are primary and secondaries.
Right.
And you could have multiple secondaries, but you only have one writer node. But then there's also, I feel there's a difference between a distributed database and a sharded database.
That's right.
And people say, what's the difference? I mean, aren't you just sharding the database or sharding the data underneath? From my perspective, it's from the app developer's perspective. If they have to know where the data is, it's sharded. So they have to know, I need to go to that instance to get data for John, and I need to go to that instance to get data for Jim. That's a sharded. But if they can just go to any instance and just, or any node and just ask the database and they're going to get a consistent response back, that's a distributed database. Yeah.
Well, and that's right, John. And it's actually a nuance in what you said, though. It isn't that they have to go to a particular master node and say, hey, can you find this for me? And it's going to find it for you.
Right.
That's like Vitesse. That's like Citus does that, right? Like, no, we're talking any node is a gateway. Any node, you can ask any node in the entire system, and any node is going to be an endpoint and a consistent gateway to the entirety of the database. And I think it's another level of nuance that I didn't really understand until I was here at Cockroach. It took me a couple of months to actually really understand. Oh, wow, that's kind of cool. Like, that is what allows us to spin up a node anywhere and have access to the database, right? Like
all the database, fully consistent.
Yeah, exactly. So, Tim or John, I don't know, did you guys dive into any of these other questions that you want to actually talk through? I'm sorry, there's a lot here. I'm having a hard time consuming.
Well,
Tim,
I saw a question where I think maybe I confused people on the difference between serializable isolation and consistency.
Yeah.
And I think that, because we kind of hit that at the very beginning, and maybe we've explained it since then, but I think the easiest thing, and this ties back to the CP AP conversation, but the easiest example I can think of is of a non-consistent database is think that you have a primary and a secondary. And so the primary is replicating the secondary. And let's say the secondary is 30 minutes behind or 10 minutes behind or something like that. And then the network goes down between the two. So now you basically have two different databases at different points of time. Now, if you, it'd be fine if you never wrote to this one, but let's say the people over here say, well, we got to write to the database. You start writing to this database and you're still writing to this database. Now these two databases diverged. So they now have different sets of different set of data. That would be a system that is not consistent. And so that's what I would call an AP system, because in the presence of a partition, both systems are available, but now they are no longer consistent. They basically show different versions of the answer. So when we talk about consistency, we're really talking about, what is the state of truth of the data, and isolation's more about, in a transaction, what side effects do I see in my transaction? What state changes do I see happening to the database while I'm in the middle of my transaction that has a begin and an end? That's really what an isolation is. Hopefully that made sense.
Yeah.
Yep.
It was a good, I was going to hit you at the very beginning, John, but I figured you'd see that and get into it a little bit more. So let's talk about, Tim, we were talking about atomic clocks here. I think there were a couple questions about that. And again, by the way, before we even get to the end, I always like to give a shout out and all the kudos in the world to our documentation team.
Mhm.
Everything that we're talking about right now literally is in our docs in a much better, more eloquent way. John, you're a great speaker, but Jesse and team do a phenomenal job in our documentation. Tim, I'm not even going to comment on you. So any and all these questions, like there's one section in particular in our docs I really like. It's life of a transaction in Cockroach, and it really does go through this in very good detail. The architecture section is phenomenal. So if you are interested in learning a lot about how we do it in particular, I do have to go there. I want to talk about a little bit about atomic clocks and Kubernetes, Tim. There was a couple of questions there I think you had answered, right? So, you know, we talk about isolation levels, you know, how does that impact your decision to deploy on Kubernetes or not? I mean, it's kind of an easy softball of a question, but, you know, how does that, what do you think about that?
Well, in my mind, you know, those are two very distinct discussions, Kubernetes and atomic clocks. Happy to kind of touch on both. You know, given that we are a fundamentally distributed database, as we've discussed, and I think as previously mentioned, every node is a node is a node. So you can just spin up, you know, kind of all of these CockroachDB nodes, and they're participating against a single logical cluster. It really is just such a natural, easy fit for deployment on container orchestration systems like Kubernetes. So obviously you can deploy Cockroach in the cloud, and with cloud provider native technologies, you can deploy on-prem, VMs, et cetera, et cetera. But it turns out we're just an excellent fit for deploying inside Kubernetes. So just like you might be deploying your applications, your microservices inside Kubernetes, you can deploy your database there as well. And it's just a wonderful fit. And what does that mean? Well, it means you get to take advantage of all the kind of resiliency that the orchestration framework and scheduling that the orchestration framework provides out of the box. So if a node goes down, instead of having to go, you know, push the power button or some other mechanism, you know, Kubernetes will notice that failure and restart the node. So it's really a wonderful mechanism to handle that, to deploy. So we're seeing a ton of pickup in deployments of Cockroach inside Kubernetes. In fact, we have a Cockroach Cloud offering, which you can learn more about on the website, I suppose. But that is natively or behind the scenes deployed on Kubernetes. So we think very strongly of that. How do we handle storage? So persistent volume claims is how we do that, and stateful sets. We currently today publish a Helm chart. We're building an operator. We've made tremendous progress. We should have an operator kind of GA in a month or so. The reason we haven't done it thus far is because, again, we fit so well into native Kubernetes patterns that it hasn't necessarily been required. Why is all that possible? Why can we deploy all over the place in all these weird environments, but technologies like Spanner not? And I think that's kind of how we make the connection here to atomic clocks. Is some of you may know Google Spanner, from which we drew considerable inspiration early on. In fact, our founders were all ex-Google, early ex-Google employees. Google Spanner is kind of similar in concept. It's a distributed OLTP engine, but it requires very sophisticated infrastructure that only Google can provide. And one part of that infrastructure are atomic clocks. And they use atomic clocks to help narrow kind of the uncertainty window with transactions into a very kind of tight window. And they've, you know, without getting into all the details, that's how they make it work. We've made other design choices because we want to be able to run anywhere at any time. We don't want to require specialized hardware to run. And so there's a great blog post. I answered some, Olaf, I think his name was, posted a question about that, and I posted the link. We can follow up with it. But there, Spencer Kimball, our CEO and founder, wrote a wonderful blog about living without atomic clocks, and goes into great articulate detail about the choices we've made there.
Really good.
I think it's the most popular blog post on our entire thing, and I mean, kudos to our engineering team. Again, I guess I'm giving kudos. All of a lot of our stuff ends up on Hacker News because like the content is just extremely valuable. I mean, the way we do it, Tim, we're using NTP and then a logical drift, right? Software to actually deal with that, right? So there are ways to do it. You know, go on, John, please.
Yeah. I was actually just going to make a shout out to Crony to synchronize your clocks. It's one of our best practices. NTP is like very old school. We don't use NTP anymore. There's like NTP, there's time date CTL, and then there's Crony. So If anyone's listening and you're thinking about how to synchronize your clocks, use Crony.
I guess I'm just old school, John.
Yeah, NTP.
I'm not
yeah,
sure,
we know
show my
nobody
age
uses
here.
NTP
You guys look
anymore.
older than me, but I'm not gonna.
If you're using
Hey,
NTP, switch it, because getting synchronized clocks as close as possible just gives you much better performance. Yeah.
Well, let me ask you. This is an oddball. This is this is a question I have. Then why not use something like TrueTime, right? So I know Google has that as a service, and Amazon now has that as a service as well over the past couple months, right? Are people using that as well? Like, there's a cloud service to synchronize clocks, right?
Yeah, I think for us,
John, or Tim.
Well, I was going to say, I think for us, the important thing here is we want to have a consistent kind of source of time. So what you want to have is kind of pick one, and there are certainly some that are better than others, but pick one and have all nodes, regardless of what infrastructure they live in, have access. So, one of the hidden kind of wonderful things about Cockroach is you can deploy a cluster that spans multiple cloud providers. And so what you don't want to do is, your Google nodes using Google's time oracle and your Microsoft nodes using Microsoft's time oracle.
Interesting.
Right? So you got to make sure that is there. I was going to answer, just while I've got a hot mic here, another question, if I may, Jim, unless you wanted to.
Yeah, no, please, Tim, by all means. We have 3 minutes, so.
So there's a kind of Victor was kind of asking an interesting question about, from a security perspective, can we alert on significant transaction anomalies, which I thought was actually a fascinating idea. We've been talking about it, but we don't have like a good way within the UI necessarily to say, hey, this particular anomaly may or may not occur. I mean, the reality is, because we implement serializable isolation, transaction anomalies like we've been discussing aren't going to happen. But what can happen are things like retries. And so the UI does notify, or does increment or count when retries occur. And we've got some great tooling around statements and all the other stuff, which is beyond the scope of this discussion. What I really wanted to say here is we have a very feature-rich UI that you can pull and see all sorts of great information and metrics. We expose all of that stuff via Prometheus. That, in combination with other endpoints, has been used by companies, for example, like Datadog, to build monitoring solutions around Cockroach. So I think kind of the broader kind of answer to the specific question was, there are lots of mechanisms and ways to monitor and get really rich data out of Cockroach, both from our UI specifically or endpoints that we publish that allow you to consume that information and put it in all sorts of other alerting mechanisms. So, you'll know what's happening inside a Cockroach cluster, given the tools.
That's right. That's right. Well, cool. That was a good last question, Tim. Just one last thing. Again, our docs go into all this stuff. We do a fine job. You guys, thank you so much. Like, that was really one of the best conversations we've had on this type of session. But again, to the crowd, I mean, our docs do a great job. Go in here. You can start a Cockroach Cloud cluster today. We'll give you a free cluster for 30 days. You can download Core, talk to us about enterprise. So hey guys, I'm in marketing. I got to have my one call to action, right? So we make it pretty easy, but our docs is available right here on our homepage. Just come learn and click docs. And a lot of this stuff that we talked about is in here. The learn more section in particular, I find to be extremely interesting. So, so with that, first of all, thank you guys for joining. That was John. That was fantastic. Thank you so much. And Tim, as always, that was, you're double tasking, dual timing, doing the questions and everything else is just great. So I know JP did put in some, we're going to send out a Cockroach mug with a little cockroach on it. It's actually the cute Cockroach logo, out to some people who made the best questions today. So he will follow up with that. I think there were 5 winners: Robert, Colin, Rod, Edgar, and Jillian. So we'll follow up with that. Guys?
We really should be sending Olaf a mug for the use of the word Byzantine in a question.
Right? We can do that.
I'm looking up right now.
Are you making game time decisions here? I like it.
No, I'm not. Hey, one other question I thought maybe we should just answer real quick. Do we have time, or we?
Yeah. Whatever you want, Tim.
What happened, there was an interesting question. Again, it's very related with regards to reads. Will reads happen from master or from replicas too? Great question. And I think we might've teed it up early, but didn't really go there in great detail. So by default, Cockroach will serve reads and writes from what we call the leaseholder, or the authoritative record or copy of the data, in the parlance of the question, the master, right, for a particular range. But you can, and there are a lot of reasons to do it, you can allow Cockroach to serve reads from replicas or copies of the data. And the feature that this generally falls under is something called follower reads. And the way you trigger that is you issue a specific kind of query to a Cockroach database. So, instead of select, star from users, where ID equals Tim, you would issue a query that looks more like select star from users where ID equals Tim as of system time.
Right.
Minus 30 seconds ago, essentially.
That's
and what that does is that triggers within Cockroach the ability to return data, not just from that leaseholder, that authoritative or master copy of the range's data, but actually any one of the replicas that exist in the system. And there's lots of great reasons to do that. So yes, you can do it. Yes, it's an optimization that we sometimes recommend for certain topologies or workloads. So thank you, anonymous attendee. Strange name, but a great question.
Yeah, I'm going to start joining things as anonymous attendee. There's the whole select for update too that we didn't even get into, and there's a whole bunch of stuff about optimizing Cockroach database that we can get into. I'm sorry, Andy Woods, in advance before you asked me. We didn't cover that thing. So, guys, thank you. But more importantly, thank you to everybody who joined today, and for all of you who stayed on even in the overtime here. For doing this with us. Guys, thank you. That was, I think, one of the funnest conversations I've had since I've been at Cockroach. I'm happy we recorded it and got questions from other people. So, all right. Well, guys, shall we say goodbye?
Yep.
Yeah.
Thank you.
All
Thanks
right.
for having us.
Thank you, everybody. Have a great day.